Welcome back to the lecture on microcontroller and its application. In this lecture, we'll study about interrupt module in 8051 microcontroller. So what is basically an interrupt? So we studied about interrupts in other microprocessor classes also. So what is an interrupt? Interrupt is basically an operation which will interrupt or which will stop the main course of the program. And will take the program to a subroutine. It will execute the subroutine and will bring back to the main course of the program. So that is basically an interrupt. So an interrupt can be an example, a classic example of interrupt can be on a mobile phone when you are texting or when you are when you're browsing your internet on your mobile phone, and if a call comes, always calls get the priority over your text. Now that's an interrupt. Now your main course was you were texting or busy doing something else, but you get a call. Now that is an interrupt, and that is given a precedence over whatever you were doing first that time. So that is basically an interrupt. Now basically in microcontroller there are two types of interrupts. Now interrupts are basically used to give priority to a specific operation in the microcontroller. Now, there are two types of interrupt. One is software interrupt and the other is hardware interrupts. Now, what is software interrupt? Software interrupts are basically based upon the internal operations, or they are based upon the status of the flag register. But the hardware interrupts or the hardware signals or the interrupts are are based upon an external trigger or one of the bits in an interrupt enable or interrupt priority register. It is based upon a trigger. Okay, so there are these are the two types of interrupts. Okay, now the software type of interrupt, that is to keep on checking if there's a flag, if the flag is set or not set, is kind of intensive, process intensive. But hardware type of interrupts are not very process intensive. So let's see what are the different interrupts that are available in 8051 microcontroller. 8051 microcontroller has 5 different interrupts. They are timer flag 0, timer flag 1, serial interrupt, and external interrupt 0, and external interrupt 1. These are the 5 different interrupts, and as I have classified there, the top 3 interrupts, that's timer flag 0 and timer flag 1, and serial interrupts are generated by your internal operations. That is, it is generated kind of automatically through your microcontroller. So the other interrupt, that is external interrupt, are actually received on your port 3 pin. If you remember, port 3 pin is multiplexed with some 2 interrupt pins also. So if there is a signal generated there, or if there is a signal received there, then you actually get an interrupt. So that is basically 5 different types of interrupts. Now, whenever there is an interrupt generated, now any one of these interrupts generated and your program goes to a subroutine, for your program to return back to the main loop of program, a simple return statement will not be enough, as you studied with call statement RET. Here, when a program has to come back from a return, interrupt instruction, RETI instruction is to be used. So the program will come back to the main program from where it left the program. So let's see what is an interrupt enable special function register. As you know, to do any process in a microcontroller, you need to configure that process, or you need to configure a register. A control word needs to be written to a register. So the register that is associated with interrupt enable and interrupt priority register basically. So interrupt enable register, as you can see, there are 7 different bits in interrupt enable register, and the first pin, that is, or the most significant bit, houses enable all pin or EA. If set, if this pin is set, that is, if this bit is written as 1, all the interrupts will be enabled. Your timer interrupts, your external interrupts, your serial interrupts, all the interrupts will be enabled. If you want to individually enable an interrupt, for example, if you want to enable timer interrupt, or if you want to enable the serial interrupt, or you want to enable timer 1 interrupt, or if you want to enable external 1 interrupt, each of these interrupts can be enabled by writing a 1 to one of these bits. But if you write a 1 and to enable all the interrupts will be enabled. But otherwise, you have to enable each of these interrupts. Once this is enabled, only your interrupts will be active, or you can call an interrupt, or the interrupt will happen. Otherwise, an interrupt operation will not happen. Now, this register is bit addressable, so you can address each bit rather than addressing the entire register. That is interrupt enabled register. So apart from interrupt enabled register, interrupt priority register is a register which gives a priority to all these interrupts. Now suppose a case happens where more than one interrupt comes to the microcontroller at the same time. Which interrupt should be given priority? Then in that case, whichever interrupt is given higher priority by you as a programmer will take the topmost priority. There is a default priority that this microcontroller will have in effect, but if you want, you can give a highermost priority to a specific interrupt. For example, as you can see in interrupt priority register, these 5 bits, that is priority for timer 2 interrupt, or priority for serial interrupts, or priority for external interrupts. If any of these bit is set as 1, that particular interrupt will have the highest priority. That means if you set external interrupt 1 as 1, external interrupt 1 is equal to 1, or if you set that as equal to 1, then this, whichever interrupts come, this interrupt will have the highest priority. So that is how you set the priority for interrupts in your 805 macro. But what if all the interrupts are set as 1, or all the interrupt priority special function register is set as 1, all the bits are set as 1? Then there's a default priority also, which is given over here, the interrupt priority, where IE 0 or external interrupt 0 has the highest priority, and then the timer flag 0 has the next highest priority, external interrupt 1 has the next highest, timer flag 1 has the next highest, and serial interrupts have the lowest priority. So that is how the interrupts are processed. So apart from this, the other the other registers like tcon and scon have flags related to this interrupt. For example, if you see the tcon register, your your external interrupt 1 and timer interrupt 1 and external interrupt 0 and timer interrupt 0 flags are housed here, and your transmit interrupt and receive interrupt flags are housed in serial communication register or serial control register. So there are basically 5 interrupts, and these 5 interrupts can be enabled using interrupt enabled register, and these 5 interrupts can be given a priority using interrupt priority register. Okay, so that is the basic funda behind using interrupts. And there's a default priority order for these interrupts, as you can see over here, and the highest priority is given to interrupt external interrupt 0, and the lowest priority is given to serial interrupt. So that is how the interrupts happen. Apart from these interrupts, there is one non-maskable interrupt which is called as reset pin. So whenever a reset pin will have a value, or whenever an reset interrupt is generated, it will take the topmost priority. It is a non-maskable interrupt. That means it cannot be prioritized. It cannot be given a priority order. It will always take the highest priority. So reset is a non-maskable interrupt. All the other interrupts are maskable. That means they can be given a priority. So all these interrupts are actually vectored to specific address location. As you can see, external interrupt is vectored to this address 0003, and timer flag interrupt is addressed to this address 000B. Serial interrupts are addressed to this address 0023. So they have a specific hardware. You need not specify, the program automatically goes to a subroutine to the specific address. So that is what about interrupts. So there are 5 interrupts, and these 5 interrupts are 2 external interrupts, 2 timer interrupts, and 1 and serial interrupts. All these interrupts can be enabled by interrupt enabled register. They can be given a priority by interrupt priority register. By default, there's a priority order, as we saw, and they have a vector address. As you can see on the screen, they have a vector address. So that is what is basically about interrupts. The next lecture we'll see about timers.